Okay, in this video we're going to do a couple more integral problems just to make sure that we have a good understanding of it. Again, in this problem we can't actually take the antiderivative or the integral of each piece individually, so what we can do here is multiply the products times each other first, and then we take the integral. So if you multiply this out, we will get x squared times x is x to the power 3, x squared times 1 is plus x squared, 3 times x is plus 3x, and then 3 times 1 is plus 3 dx. Now we can take the derivative of each part individually with no problems. You can see here that there's no like term, so there's no much you can do actually. So just like normal procedure, what we do is take a derivative of each piece. So x to the power 3 would become x to the power 4 over 4, and you know this is just adding 1 to the new power to the power and then dividing by the new power. Same thing for here, we've got x squared, so it's going to be x squared over 2, sorry, x3 over 3, adding 1 to the power. 3x, well, the same thing, x to the power 1 will plus 1 over 2, the new power, and the integral of 3 is just 3x, and then don't forget our c, the constant. So yeah, that's the integral of it. So the main idea of solving such equations, the main idea of this is if you can use algebra, it would be a lot easier, make your solution a lot easier, but sometimes you can't use it and you got to do it in other ways, like integration by parts, substitution, partial fractions, but we will cover this hopefully in the next videos. But again, if you can use some algebra, it'll be a lot better. Algebra is always useful when doing integration and differentiation as well. Alright, another example here, the integral of 1 over 3x minus 2 all squared dx. So before doing anything, what I like to do normally is just tidy it up a little bit, and by that I mean put the denominator up and change the sign of the sign of the power. And that's what I'm going to do now, is just put in the denominator because it just looks a lot neater. The power minus 2 dx. Now remember the chain rule in taking derivatives, the chain rule. Well, we're going to kind of use similar. It's not called the chain rule, there's no chain rule in integration, but I like to call it like that because it's very similar. It's just the opposite way, because integration, as you know, is the opposite operation of differentiation. Oh, it sounds like a rhyme, isn't it? It just sounds tongue twist. Anyway, so we let's consider what's inside the bracket, the parentheses, 3x minus 2. Let's consider as u. So u equals 3x minus 2. So let's just substitute that with the whole thing was u to the power 2, right, dx. Now let's take the derivative of du dx, of u, which is du dx. And the derivative of what's inside the parentheses is simply just 3 in this case, isn't it? So now look, if we arrange it, we can, by making dx the subject in this particular piece, if we rearrange it, we get dx equals du over 3, right? So what we can do here is we substitute dx here with du over 3. So we end up with u to the power minus 2 du over 3 right? So we literally integrate and on respective with respective of u. So if we integrate this, just normal procedure, -2 become -1 and over -1. So we don't have to write over -1 because just put a minus here. It's just the same, just different sign. And now we add 1 to the power and then du over 3 and then plus c. Don't forget about the constant. Let me just move out a little bit because I'm running out of space. Let me just rewrite it here again. So -u to the power -1 du over 3 plus c. Now what we do is just substitute, put u back in the original form, which is what was inside the parentheses, right? So we substitute u with 3x minus 2, and then to the power -1, and then just put over 3 here, and then plus c, and that's your final integral. I like to call it the chain rule integration, but it's not quite the same, so it's not official, but I like to call it that way just to make things easier. So yeah, what we do is we basically take the derivative of what's inside the bracket, and normally the chain rule is we take the derivative outside the bracket, times it with that, then derivative inside the bracket, and then times it, and leave the inside as it is. Well, in this case it's kind of similar. We take the integral of outside the bracket, add 1, which is going to be -1, and then derivative of that, instead of multiplying it, we divide by the derivative inside the bracket instead of multiplying it. So that's what we basically did. If you compare the original question with the answer, you would see that we took -1 times it. We add 1 first, then times it. We got -1 for new power, and derivative inside we divided by it. So yeah.